Hello, DiplomaEdge students, and welcome to this series of videos on chemistry internal assessment. We're going to start talking today about how to choose an idea for the internal assessment that is successful. So what actually makes an IB chemistry internal assessment successful? In the future, we're going to be talking about the biggest mistakes students make when they choose an internal assessment. We're going to see what examiners actually are looking for when they are marking your internal assessments. We're going to see how to interpret the criteria so you can maximize the marks per criteria. And finally, we're going to see some examples of investigations for you to understand what makes a good investigation good. And the first thing that we're going to be talking about is the topic selection. Why is it so important? When you're at the end of the first year, in probably April or May, you have to start thinking about the investigation that you are going to be doing. And probably over the summer, you're going to process the data and then get the draft finished in September. Different schools, different timeframes, but this is very typical. Okay, so why is the selection of the topic so important? It's the most important decision in your internal assessment, because sometimes if you don't select the topic well enough, you find out when you are processing the data that you are not getting good data, the analysis is not good, and the investigation doesn't get high marks. So you need to change the investigation later in the year. So some weak internal assessment ideas are not recoverable. They cannot be rescued at the end. If you choose a good topic, you are going to have a decent methodology that is going to give you good data. And when you get good data, the depth of your analysis is going to be better. Your conclusion is going to be much more solid, and your evaluation is going to be much more meaningful. So what is the biggest misconception that students have when they have to choose the topic? I think, in my experience, the biggest one is that you tend to think that the most complicated the topics, the better are going to score in the IB. And this is really not true. When a topic is overcomplicated, it's normally difficult to control. Sometimes it's going to generate data that is unreliable, which is going to lead to a weak analysis. The methodology sometimes is not realistic because you may not have even the tools to do it properly. And the conclusions many times are superficial. And on top of that, you don't understand well the topic that you're doing. You're not familiar with it. So sometimes it's counterproductive to choose something that is very complicated. Whereas if you choose something simpler, but still good for chemistry, your data in your experiment is going to be way more reliable. This is going to allow for a much deeper analysis, much clearer connection to chemistry, much more meaningful evaluation, and a stronger conclusion. And this normally renders better marks for your internal assessment. So simple sometimes is more advisable than very complicated. So what are examiners actually looking for when they are reading your internal assessment? Well, the first thing that they are looking for is an internal assessment in chemistry. There have been many complaints over the years that candidates actually or students choose investigations that are not directly related to chemistry. An internal assessment, it has to be a chemistry one. So chemical relationships or something, variables that are measurable, that are to do with chemistry, chemical analysis, reaction behavior, molecular interactions, etc. Things like health issues, biological processes, or comparisons that are descriptive are not a good idea in chemistry. So when you select your variables, number one, they have to be measurable with the tools that you have in the lab, and you have to select variables that are directly related to chemistry. Some things that can be interesting are things like pH, or change in mass, or absorbance, or reaction times, things like that. The methodology that you're using has to be feasible, has to be a methodology that allows you for the collection of good data, and it has to be a methodology that you can actually do with the tools that you have in your school lab. The data has to be sufficient. The methodology has to provide you with enough data that you can actually do an analysis of the data that is meaningful, and you can get a conclusion to answer your research question based on that data. Also, you need to have an evaluation that is critical. You need to evaluate, especially the methodology that you have been using. So, once you have decided what topic you're going to do, what does it make it a good test? Well, ask yourself these questions. Question number one, is it really chemistry? If it's not really chemistry and it's more biology, it's not a good investigation for chemistry. Can I measure the variables reliably? The variables that I have used, I have the tools or the apparatus in the lab to measure them properly. Are they going to give me enough data? And is the data going to be quality data? Is the experiment realistic in a school lab? Or do you need things that you don't really have access to? Will the data allow for a meaningful analysis? So are you getting data that is giving you patterns or trends that you can identify in the analysis? And finally, can you explain the chemistry behind your investigation? Do you understand what you're doing? This is very important. Many investigations fail because the idea itself is not very strong. For example, comparisons between products or brands. Which toothpaste is the best? Or what soda is more acidic? Yeah, we know that you have to do a titration, but think about it. The analysis is not going to be very good. At the end, you're going to get something like this soda is more acidic than this one. And that's all the analysis that you can do. So comparisons are normally not the best. Which sport drinks is the healthiest? No way. Verification investigations are not the best either. Things that you already know because you have done them extensively during the year in the practical program. How does temperature increase the rate of reaction? Well, you have done it 1,000,000 times. Does concentration shift the equilibrium? Well, okay, it's related to chemistry. It's not the best because you already know the exact answer before you do the investigation. And then projects that are unrealistic, also not very good because university level analytical methods, for example, or methods that require an equipment that you don't have, or using models that are so advanced that you don't really understand them, are not going to give you good data and you're not going to do a good analysis. So a strong analysis is impossible if you don't get good data. And to get good data, number one, you have to have enough repeats. Now, how many repeats do you need in an investigation? How many times are you doing the same experiment for the different increments of the independent variable? Well, the absolute minimum is 3, because without 3, you cannot identify odd results. So 3 should be the minimum. We are expecting you to do more than 3, at least 5. Now, if your experiment is taking a long time and it's reasonable that you don't have the time to do more than 3, go for 3, that's the minimum. But if the experiment goes relatively quick and you have the time, at least go for 5. The measurements that you are getting, they have to be reliable. Do them with something that has a good precision. For example, if you're measuring the temperature and you're using a traditional thermometer and the uncertainty is plus minus 0.5 degrees Celsius, if the differences between the different intervals of the independent variable are 1 degree, the uncertainty is just too high. So you either have to use a better apparatus that is more precise, like a temperature probe, or when you design the experiment, you should have gone for larger increments in the independent variable that allow you for a better comparison. You need to have enough data points. So the variable range, your independent variable, has to have enough intervals. We are aiming for a minimum of 5, but you can go for more than 5. And the uncertainties, as we said before, have to be manageable. Have to be uncertainties that allow you for an analysis and a good conclusion. And then finally, when you do the investigation, you need to be able to see good trends or good patterns that you can identify, because if you don't get any patterns or any trends, suddenly the analysis is not going to be very good. So, in a nutshell, in this first video, we have said that strong internal assessment topics are scientifically focused. We have said that quantitative variables improve the analysis, so numbers, because you can get more analysis from a set of numbers in the independent variable than from something that is qualitative, like different sport drinks or things like that. Good data produces strong conclusions. Simple investigations often outperform much more complicated ones, basically because you understand them well. And finally, feasibility and data quality matters the most because without good data, you cannot have good analysis. Without good analysis, you cannot have a good conclusion and evaluation. And that's all for this video. Next video, we're going to be talking about the biggest mistakes that students make in the chemistry internal assessment. I'll see you there in DiplomaEdge.